Hello, it's Tim with Wolfhound, and if you can look past the mess on my workbench here, I can show you my new project. I'm building two battery banks, Lithium Ion 18650. These two battery banks will be 8 in parallel and 5 in series. 5, 1, 2, 3, 4, 5. Right now the wires aren't long enough to spread them out that far, but they will be eventually. The power leads are going to come off of one side of this for charge and discharge, and on the other side is the battery monitoring and balancing leads, which will go to the BMS, which I have a BMS here. I don't know how well this is going to be. I've also got another one, a battery go balancer and a checker. And so this is what this project is involving is actually I'm changing my solar power system. I have a small 200 watt solar power system, and I'm converting it from lead acid to 18650 battery banks. So I'm building two of these banks. There's another already pre-drilled panel here waiting on some more, and there's also another set of battery holders already wired up here. A lot of this has been built. I'm not quite ready to screw this down yet, or actually I am ready to screw it down. One end of each one of these has a bus bar or bus wire going across of it to get the power in and out of it, and on the other end are fuses. These are 5 amp fuses. Each one of these cells, every individual cell has 5 amp fuses on them in case there's a short or a reverse polarity or wiring problem. We've got a 5 amp fuse. It's a soldered fuse, so if it blows I have to actually go in and resolder it. Each one of these fuses are going to wire in pairs to these tabs that are on the back of these battery balancing wires. Each of these sets of battery holders has 4 tabs, and each tab will get two wires going to that tab to complete the circuit all the way down the stack here. The total voltage will be between 14 and 21 volts depending on the charge, and will eventually get used at the 12 volt level, and almost everything is coming off the battery will be running with buck converters to keep the voltage under control. And there'll be a lot of LED lighting too, which doesn't really care. It's already got current limiters in those to keep them going at the proper current level. So anyway, this is just almost about ready to screw this down and get it put together to go in the battery thing. Okay, so here we are with them fully finished. There are 2 of them. There's a couple of batteries already just put in just to kind of check the voltage, make sure everything's up to goodness. There's in between each battery pack are individual fuses for each cell. These originally came, the terminals at the ends were too small to handle the batteries I have, and so I had to take some pliers and squeeze these. I had to squeeze each one in, and now it works very well to hold the batteries in. There are balance wires coming off the end of each battery. The positive rail off the end here, and the negative rail is basically just straight across the back of the batteries. It's a 14 gauge wire coming off both packs, and these packs, the negative wire goes to 5 strip terminal. I'm going to using 5 out of these 6 on here, and it's the same with the positive side. So doing coming out to 6, so I can get all the charging. This is for solar power, so I've got to go charging in and discharge out, and there's several things needing to go to the batteries. The balance wires are they're also the same wires that the fuses solder to, the little tabs here, and it's also the bus wire across the battery for the balancing. And I think it's 20 gauge wire. That's what my wire gauge, my strippers were measuring, was about 20 gauge, which should be good for 4 amps or more. And then these wires come out to this terminal strip here, which will have the it's going to have the balancing chargers and testing meters, and it's even going to have a line going inside the house to so I can monitor all of these cell voltages from each of these parallel surfaces. So this is basically ready to cram the batteries in and hook onto my solar power system, which right now has no batteries. I'm actually running it off of capacitors, and which is no real power capacity there, but since most of the system runs off of buck converters, I don't have any it works really well. So should be next we'll be looking at this thing full of batteries, and here it is, almost ready to install. And so both battery banks already populated with some of the batteries. I only have enough batteries to fill up one of them and one more row, or 9 rows. Eventually this will be a 16 parallel by 5 series, making 21 volts at about 40, hopefully 40 amp hours. The outputs from these 2 battery banks come to this terminal strip here. Right now it's just got a battery plug on it, so all the ins and outs to the batteries come in right here, and the balancing wiring for the charge controller comes out and comes down to this small panel here. And right now I have 2 devices plugged into it. One of these devices is coming out of these JST connectors. One of these devices is the actual charge controller and protection. This keeps the voltage from going below 2.8 volts or over 4. I believe it says 2.3 volts. And it also prevents charging if the temperature is too low. And that's ready to install that. And then I also have this Battery Go monitor here. It's actually showing the bank right now as it is. It's 18.94 volts, and then all the cell voltages. They're only 73 millivolts from lowest to highest, and it's charged at about 53%. And so this also does balancing. These both of these devices do about battery balancing. So eventually it should pull them all together into one good solid voltage. So this is actually ready to install on the solar power now. I've actually had it hooked up to it temporarily as kind of a hack with the wiring, and it's been working very well. It worked all night on half an amp, which isn't much, but it only went down 1 volt during that time. Actually only went down 0.6 volts, and I'm anxious to get this hooked in and working. Got a little work to do on the solar power to accommodate this 21 volts output, but it's I've already got the parts. I've been working on it today already, so time to go put this in. Looks like this will be the final resting home for the battery banks in this cooler here. They were actually built to fit this cooler, and this is the 2 battery banks right here. I've got the batteries divided in half to equal the load coming off of them. Coming out mainly to here. Charge controller is here. This is a balancing charge controller, and everything will these 2 wires right here end up going to the inside of the house, where there's a power distribution and a bunch of LED lighting and fans and low power stuff. I don't use much over 2 amps at a time, so it's a really small system. It's only about 80 watts of panels up here, and so all I got to do is hook up the battery. This will go to those 2 wires, and which leads up to a fuse panel, and everything from the batteries goes through these fuses. Everything in and out of the batteries is these fuses right here. And there's some other stuff. There's solar panel combiners, and this was actually built to handle a wind generator too. And this is an old charge controller. It's a dump load controller that was used on the original lead acid batteries. So I'm converting to these lithium. So it's just a little bitty small system, and this is where these will live. And I have another video about how this solar power system is working a little later. So that's the end of this build, and on to the next thing. Thank you guys for watching, and this is Wolferhound out.